So chapter 5 would be on equilibrium of a rigid body. Now in previous chapters we investigated equilibrium of a particle. In this chapter we're going to explore what is equilibrium of a rigid body, and this chapter is divided into 5 sections. In section 2 we will study free body diagrams for the rigid body, and in section 3 we're going to explore what are the equations for equilibrium of a rigid body. Section 4 would be about 2 and 3 force members, and the last section we will delve into constraints and determinacy. So let us first define what is a rigid body. Now, as previously discussed, rigid body is a combination of particles that remain at a fixed distance with each other. For example, you have so many particles, and these particles are supposed to stay at fixed distance with each other. So the distance from one particle to another will always remain the same, and this makes it a rigid body. Now, for a rigid body to be in equilibrium, we have to satisfy two conditions. Now remember, for a particle, we had to satisfy the condition, that is summation of all the forces should be equal to 0. Now for the rigid body equilibrium, instead of one condition, we have to satisfy two conditions. Now these two conditions, because in a rigid body, in addition to the force, you also have another thing that is called moment, which we have discussed in the previous chapter. So if this resultant force and a couple moment are 0, only then we can say that a rigid body is in equilibrium. For example, let's just say this is a rigid body and we have so many forces acting on it. This is force 1, this is force 2, force 3, force 4, and we also have moments, because the force, if the force is not acting on the point O, arbitrary point O, if the force is acting some distance to that arbitrary point O, then you will have, in addition to forces, you will also have moments. Now we will go deeper into this arbitrary point O in later chapters, but for now you have to understand that there are two conditions for a body to be in a equilibrium, and the first condition is summation of all the forces is equal to 0, as was discussed in the equilibrium for a particle related chapter. Now this has another, for a rigid body equilibrium you have another condition, that is summation of moment is equal to 0. So if you have a rigid body and you have different forces acting on that rigid body, and if the summation of all the forces is equal to 0, and also you have different moments acting on that body, and if all the resultant of all that moment would be equal to 0, then you can say that this rigid body is in equilibrium. For example, in this case we had so many forces acting on it and also the moments, and let's just say all the summation of all those moments is this moment, and the summation of all these forces is this force. So if this force and this moment is equal to 0, then we can say that this rigid body is in equilibrium. What is a free body diagram? By definition, it is a drawing with all the external forces that act on it is called free body diagram. So basically you have a free body and you try to figure out what are the external forces acting on that body. Now before going into detail about the procedure, we can go through something called support reactions. So I have shown three type of support reactions in this slide. One type of support reaction is called roller, another type of support reaction is called pin, and another type of support reaction is called fixed. Now to really see how this pin is formulated, you can see this cross section. So basically the pin is made up of leaves, pin and member, and then combine makes it a pin. So why understanding these support reactions is important is because when the forces are applied on it, you have a reaction forces as well, and that reaction forces are coming from the support reactions. So remember, as we have previously studied, that there are two type of forces, an action force and a reaction force. Now this reaction force comes from the support reaction, so that's why we also need to understand these support types and which support type provide which type of reaction. So basically this roller support will provide one reaction, and this pin support will provide two reactions, and this fixed support will provide three reactions. Now, in order to really explain how or what that support reaction means, is let's just take an example of this pen. Now, if I put this pen on the top of my thumb, then if I will apply a force on a horizontal direction, I can move this pen in the horizontal direction. That means that there is no support reactions and on the horizontal direction. But if I want to apply a force on a vertical direction, that is, if I want to move it downwards, I cannot move it downward because I have a thumb that is applying an equal and opposite force on that pen, and the pen cannot move down. So this type of support would be called as a roller support. Now, what is an example of pin support? Now, if I put my index finger on the top of it and then I put this pen here, so in addition to not being able to move this pen in the vertical direction, I can also not move my pen in the horizontal direction. So this type of support would be referred to as a pin support. Now imagine I just hold this pen firmly. Now I cannot move this pen in a horizontal direction. I can also not move my pen in a vertical direction, and I can also not rotate this pen. So this type of support reaction would be called fixed support reaction. Now in case of pin support reaction, I cannot move horizontally or vertically, but I can rotate. So this is a pin reaction. So in the case of pin, you don't have a fixed reaction of a moment, and in the case of roller, you have only one reaction, vertical reaction. And for the pin, you have two reactions, and for the fixed support, you have three reactions, horizontal, vertical, and moment. So these are basic terms, and we'll go into detail about these fixed reactions in a later chapters. Okay, so what is a procedure to draw a free body diagram? So similar to drawing a free body diagram for point, you have three steps. Step 1 is draw an outline shape. Step 2 is show all the forces. And step 3 is identify each force. Okay, so next section would be about equations of equilibrium. So there are two main equations of equilibrium. One is related to summation of forces is equal to 0, and another one is related to the summation of moment is equal to 0. And if both the conditions are satisfying, then we can say that the rigid body is in equilibrium. So let us do one example. Now in this example, you have two supports. One is a roller support at point A, and one is a pin support at point B, and there are three forces acting on it. One is 600 Newton at an angle 45 degree, and one is 200 Newton, and another one is 100 Newton. Now we can resolve this 600 Newton force into two components, a horizontal and a vertical, and then it would be easier to do the summation of all the forces is equal to 0 and summation of all the moment is equal to 0. So the vertical force would be equal to 600 sine of 45 degree, and the horizontal force would be equal to 600 cos of 45 degree. Now this was easy to do because we already have this force, and we can resolve these components by using formula fx is equal to f cos of theta and fy is equal to f sine of theta. So in this way we can resolve any force, and we have resolved this force into two components. Now how we can find these reactions? We have to find ay, by, and bx. So remember, we had two equations of equilibrium, summation of f of x is equal to 0 and summation of moment is equal to 0. Now and summation of f of y is equal to 0. Now this is for summation of forces and this is for the summation of moment. So now we have three equations and we have three unknowns. So we have three equations and three unknowns, so we can solve this and we can find ay, by, and bx. So first what I will do is that I will do summation of f of x is equal to 0. Now by convention I am applying this rule that all the forces acting on horizontal would be positive and all the forces which will be acting on the negative of x-axis on the left side would be negative. So if I do summation of all the forces along x-axis is 0, then how many forces are acting on x-axis? You have this force which is acting on x-axis, and then you have b of x, and I think that's pretty much it. So 600 cos of 45 degree, it's acting on the right hand side, so it's positive, and b of x is acting on the left hand side, so it's negative b of x, so is equal to 0. So if you do this, you can find the value of b of x is equal to 424 Newton. So this is the value of b of x. Now the next step is to do summation of all the forces on y-axis is equal to 0. So how many forces are acting on the y-axis? One is this one, it's acting upwards, so I will just put positive with sign with this, and this is ay, and this one is acting downwards, so negative 600 sine of 45 degrees, and this one is also negative because it's acting downwards. This one is also negative because this one is acting downwards, and there is no other force which is acting on a vertical direction. 1 2 3 4 5, 1 2 3 4, and the fifth one is positive b of y is equal to 0. Now we don't know ay, we don't know by, so we're gonna just solve this. So ay plus by, and if you add this, these are all negative, so it will come out to be, you can also do this, you can just move everything on the other side, so you will get 600 sine of 45 degree minus 100 minus 200, it would be minus 300. So ay plus by is equal to, now this is positive 300. Okay, so what can we do now? Because we cannot solve this equation further because there are two unknowns, so we can move towards next equilibrium condition, which is summation of moments is equal to 0. Now we can take moment at any point, we can take moment at a also, this point also, at d also, b also. So we're gonna take moment at b because in this way we have two unknowns and they both are gonna cancel out with each other. I mean because the moment at this point would be 0 for bx, by, and 200 because the distance is 0. So let us do moment at point b. So moment is actually force into distance. So since there is, the distance is 0, so 200 into 0 would be 0, bx into 0 would be 0, by into 0 would be 0. Now what is the distance between moment at this point b and d? The distance is 2 meters. So for this force, the moment would be 100 Newton into what is the distance? 2 meters. So this is the moment for 100 Newton force. And this is anti-clockwise, so anti-clockwise is positive. Similarly, this force distance is also 0. So we're gonna not include this, or even if you want to include this, you just have to multiply by 0 and then it's gonna be 0. So this force distance is 5 meter. So, and this is also anti-clockwise, so positive 600 sine of 45 degree into 5. Now we have done this force. Now what about this force? This force is clockwise, so negative a of y into 2 plus 2 4 5 6 7, so it would be 7 is equal to 0. So if you solve all this, you will get ay equal to 319 Newton. So you have ay now. Now you can use this equation, and now we have ay, so we can calculate by. So by would be equal to 600 sine of 45 degree plus 300, and ay will go there and it will become negative, so 319. So if you solve this, you can get by equal to 405 Newton. So that's how you can resolve the forces if you have a rigid body, and then you can just use the equation for summation of forces is equal to 0 and summation of moment is equal to 0, and then you can calculate this horizontal and vertical components of the reactions. Now, the next section is about 2 and 3 force members. Now, why we are studying this section is because sometimes the solution to some equilibrium problems can be simplified by recognizing the members that are subjected to only 2 or 3 force systems. So there are some members or some systems which only include 2 forces or 3 forces. So if we can recognize these systems, then we don't need to do the equilibrium equations, because then we can directly find the solution. So let us take an example of 2 force members. So for example, this is a 2 force member. This is a member and 2 forces are acting on this member. So one thing is that we have to resolve these forces into its components, horizontal and vertical components, and then we can apply the equation of equilibrium and then do all sort of calculations, and then we can figure out what are the forces, what is Fa, what is Fb. But if these forces are equal in magnitude and opposite in direction, we can see these 2 forces are equal in magnitude and opposite in direction, and they're passing from the same line of action of force. So the line of action of force is same. So if these 2 conditions are being met, then you don't need to do the equations for equilibrium to calculate the forces. You can just directly see that these forces are equal. So whatever the force F1 is, you will get the force 2 equal to that. So then you don't need to do the equations of equilibrium. Now for 3 force members, there are 2 conditions. One, if you have an arbitrary point and the line of action of forces is passing to some arbitrary point, then also you can figure out the resultant without doing the equations of equilibrium. And similarly, if the forces are something like this, then you also don't need to do the equations of equilibrium. You can just directly find the answers. The last section is about constraints and determinacy. Now, in addition to equilibrium, the body must also be constrained by its supports. So I will explain this, why it is important for a body to be constrained by its supports. Now let us discuss constraints first. Now, what are redundant constraints? If more supports are provided than necessary, then it's called a redundant constraint system. And this system is statically indeterminate. Now, what is statically indeterminate mean? Statically indeterminate means that equations of equilibrium are insufficient. Now, whatever we were doing before, we were applying the equations of equilibrium on a statically determinate system. So what does that mean? Is that you can use equations of equilibrium and then you can solve the forces, and you can calculate the reactions. But if the system is statically indeterminate, then you cannot use the equations of equilibrium to solve the system. You also need some additional steps. So for example, we have three equations, right? We have summation of f of x is equal to 0, summation of f of y is equal to 0, and summation of moment is equal to 0. So basically with these equations you can only solve three unknowns. So if you have more unknowns, for example in the case of redundant constraints, we have more support, so we have more unknowns, so we cannot solve this by using statically determinate method. That's what it means. Statically indeterminate means equations of equilibrium are insufficient. For example, you have a fixed support here and a roller support here and a roller support here. So in this case you will have three reactions. One would be an x-axis, another would be an y-axis, and then you will have a moment. And then you have one reaction here, one reaction here. So you have 1, 2, 3, 4, 5. You have 5 reactions, and the only equations you have are 3. So you cannot solve this system by using equations of equilibrium. Okay, so another thing is about related to improper constraints. Now, improper constraints, sometimes you have 3 equations of equilibrium and you have 3 unknowns, but that does not guarantee equilibrium. So for equilibrium, for example, you have this system, you have a beam, and that beam is supported by 2 rollers. So a roller can only support vertical resistance, it cannot support horizontal resistance, and this force is applied at an inclined angle. So if you resolve this force into its components, so you have one horizontal component and you have one vertical component. Now this horizontal component will apply a force horizontally, but there is no reactive forces which is gonna resist this force. So this system will start moving. This system will experience acceleration. So in this case, summation of f of x is not equal to 0. Even if you have 3 equations of equilibrium and 2 unknowns, but this system is not in equilibrium. So this is also something which needs to be kept in mind. So this is chapter 5, and see you in the next chapter.